So when you're figuring out the domain for square roots, the inside of the square root, the radicand, in this case 20 minus 4x, has to be greater than or equal to 0. Solve that out, and that's going to tell you your domain. So move the 20 over. Divide by -4. Since you're dividing by a negative, you must flip your inequality. So it's going to turn less than or equal to, and you get 5. So that inequality turned into interval notation, because that's the way that we write domains most often. You think about it on the number line, you got 5, and it's a bracket because it's or equal to, and it's going to the left. So that's negative infinity up to 5, and a bracket at 5. For rational functions, it's just the denominator can't be 0. So we take the 2x minus 1, cannot be equal to 0, and solve that out, because the denominator can't be 0. So x is not allowed to equal 1/2. Everything except for 1/2 is okay. So on the number line, it's like just having an open circle at 1/2. So that's negative infinity to 1/2, union 1/2, infinity. So to find the range of a problem that is a rational function, you look at the coefficients of x. It's the shortcut way. Coefficients of x, 5 and -3. It's everything except 5 and -3. It's just -5/3. So it's negative infinity, it's -5/3, union -5/3 to infinity. That trick only works when there's like no x squareds or anything like that in it. But that's what we're looking at right now. This means f times g of -2. So you can plug -2 into both of them and then multiply the answers together. So you can do f of -2 times g of -2. When you plug in -2, that's 2 times 4 is 8. 5 times -2 is -10. That's f. Now we're plugging in -2 for g. 3 times -2 is -6. Minus 1. And we're multiplying those two answers together. So we're multiplying -2 times -7, positive 14. F minus g of 4, you do the same thing, but it's subtract instead of multiply this time. So f of 4, 4 squared is 16, times 2 is 32, plus 5 times 4 is 20. There's f. And then when you plug the 4 into g, that's 12 minus 1. So that's 52 minus 11. 41. F of g of x means you're plugging g of x into f. So 3x minus 1 goes into f. So you replace the x with 3x minus 1. You replace the other x with 3x minus 1. Multiply and distribute, combine like terms, all that stuff. 3x minus 1 squared first. Minus 6x plus 2 times the 2 that's out front. That'd be 18x squared minus 12x plus 4. And distribute here also. That's 15x minus 5. Combine all your like terms, which is quite a few. You got 18x squared. Negative 12x and 15x is 3x. And then positive 4 minus 1, or minus 5 is minus 1. G of f is the same concept, but reversed. We're plugging f into g. So we're plugging f into g, into the place of x. So that's 3 times 2x squared plus 5x minus 1. And then there we just have to distribute and combine like terms. So that's 6x squared plus 15x minus 1. Just notice there's an issue here. Obviously, 1 times 1 is not 2. It's 1. Negative 1 times negative 1 is positive 1. So 2 times 1 is 2. So now you combine like terms. Positive 2 minus 3 is negative 3 instead of negative 1. Whoops. I'm so embarrassed. F of f of 2. That means you're plugging 2 into f, and then you're plugging that answer into f again. F of f. So first step, plug 2 into f. When you plug in 2, you get 2 squared is 4, times 2 is 8, 5 times 2 is 10. So when you plug in 2, you get 18. We're supposed to take that answer and plug the answer back into f. Now we're plugging 18 in there. Uh-oh, that's a big number. 18 squared. $324. And then plus 5 times 18. Kind of big numbers. 648 plus 90. Add that up. You get 738. Whew. All right. When I mess up on 1 times 1, who knows? Okay. F plus G of 7. That means you can plug 7 into both and add your answers together. So plug in 7 to F. That's 49 times 2. Plug in 7 there also. That's 35. So that's F. We're going to do the same thing. We're plugging 7 into G. That's 21 minus 1. That's G. And we're adding those two answers together. 2 times 49, that's 98 plus 35. We're going to add that to 20. $153, that looks horrible. Ooh, 153, that's better. That's way less horrible. Hopefully you find transformations easy, because they are. Plus 2 with the x is left 2. A minus 3 outside is down 3. A plus 7 with the x is left 7. A positive 2 is up 2. A negative in front of the absolute value is going to reflect it over the x-axis. Which means that that shape, when you go to graph it, it would be the upside down absolute value, the upside down v. X cubed plus 3 is going to take x cubed and just shift it up 3. The minus 4 in with the x is going to move it right 4. The plus 6 is up 6. The 3 is just going to stretch it vertically a little bit. Plus 2 in parentheses is going to shift that left 2. So I said it, I didn't write it. It's a vertical stretch. So stretch. Oh, that's good. All right, average rate of change. Average rate of change is slope. These are your x values. Slope is y minus y over x minus x. These are already your x's. We just need the y's that go with it up on top. When you plug in negative 1 squared is 1 times negative 3 is negative 3. Minus 1, you get negative 5. When you plug in 3 squared is 9 times negative 3 is negative 27. Plus 3 minus 1. That's negative 25. So since it's y minus y and x minus x, we need minus signs here. So it's negative 5 minus negative 25. And negative 1 minus 3. Now that's slope formula. Y minus y, x minus x. So that's negative 5 plus 25 is 20. Negative 1 minus 3 is negative 4. So our rate of change is negative 5. Same thing here. These are your x's. We want the y's that go with them. Plug in 0. We get the square root of 1, which is 1. Plug in 4. We get 8 plus 1 is 9. Square root of 9 is 3. So since slope formula is y minus y, we need y minus y and x minus x. You get negative 2 over negative 4, which is 1/2. Determine if a function is 1-to-1. That is the horizontal line test. Horizontal line test. So since we know our parent functions, that's the best way to judge these. Think about the parent function. 3 over x graphs like 1 over x. It graphs that way. No matter how you draw a horizontal line, it never touches it twice. So yes, it's 1 to 1. It is 1 to 1. No matter how you draw a horizontal line, it never touches the graph twice. And it says, if it is, find its inverse. To find the inverse, you switch x and y and solve for y. So to find the inverse, you start with x equals 3 over y. And then you try to solve for y. So you cross multiply. Divide by x. So our inverse is 3 over x. Same exact thing you started with. It's its own inverse. Kind of unique. Sometimes that happens. G of x, x squared plus 4 is the graph. You know that that's a parabola shifted up 4. Parabola shifted up 4 is not going to pass the horizontal line test, so it's not 1 to 1. So we don't even need to find the inverse. It's not 1 to 1. So x squared, but x is greater than or equal to 0. That means that you're only graphing x greater than or equal to 0, which would be only half of a parabola. When it's limited to only the right side of the parabola, it's 1 to 1. Yes, it's 1 to 1. It's only the right side of the parabola. So that means you can find the inverse. You switch x and y, so you call that x equals y squared, and then you try to solve for y. You take the square root, and you get y equals the square root of x. That's your inverse, the square root of x. Now, we do not do, normally when you do square root of both sides, you have to do plus or minus. You don't have to do plus or minus here because it said x can only be positive. You don't have to do plus or minus because x has to be positive. So you don't need the plus or minus, you only need the positive because x has to be positive. That's what it tells you. So that's your inverse. Similar concept here. We're looking at just the positive side of another parabola. This time the parabola is shifted down 3. But it's still 1 to 1. It's just shifted down 3. So you can find the inverse. Switch x and y. Solve for y. So we add the 3 over. Again, we do the square root. We don't need plus or minus because it said x had to be positive. So the inverse is square root x plus 3.